Hello friends, so in today's question, in the figure masses m1, m2 and capital M are 20 kg, 5 kg and 50 kg respectively. The coefficient of friction between mass capital M and ground is 0. The coefficient of friction between m1 and capital M and that between m2 and ground is 0.3. The pulleys and the string are massless. The string is perfectly horizontal between P1 and M1 and also between P2 and M2. The string is perfectly vertical between P1 and P2. An external horizontal force F is applied to the mass M. Take G as 10. So we have two things here. Draw the free body diagram for mass capital M clearly showing all the forces. And in the B part is, let the magnitude of force of friction between M1 and capital M be F1 and that between M2 and the ground be F2. For a particular value F, it is found that F1 is twice F2. Find F1 and F2. Write the equation of motion for all masses. Find F means applied force, tension in the string and acceleration of the masses. So this is the figure in which mass capital M, a force F is being applied. M1 is the mass which is placed above the 50 kg and it is connected through a pulley with the mass M2 whose weight is 5 kg. Coefficient of friction between the mass M1 and 50 kg is given as 0.3 and M2 and ground is 0.3 and there is no friction between M and ground. Okay. So first of all is the draw the free body diagram for mass. So as we solve the question, okay, we are obviously going to draw what will be all the forces that will be acting on the respective M1, capital M as well as M2. So in the first part, we assume we are going to find out what will be the acceleration. Okay, that will help in solving the further part. In order to find out the acceleration, what we do, we assume that there is no friction between any of the bodies. Okay, so we say let there is no friction between all the respective masses and the ground. And under this condition, we assume let the acceleration be L, A. Okay. Say, therefore, let the acceleration of be A. Okay. So which basically mean that M1 has the acceleration of A, M2 is also having acceleration A and capital M is also having acceleration A. Okay, and in all the cases it is towards right. Okay, so now we consider the friction, and with friction also we say that the friction that the acceleration is A. Okay, in the presence of respective friction, let the acceleration also be A. And then we are going to solve the various equation which we are going to get and check whether the sign of A is positive or negative. Okay. So you can say if sign of A is positive, so it means this means that the condition is true. Condition is true, that is they will be moving with acceleration as A, and if sign of A is negative, if sign of A is negative, so this basically means no acceleration. Okay, so it means acceleration is equal to 0. So we assume that the acceleration of every block is equal to A. Okay. So we can say something like this, that this is our capital M, okay, and F force is being applied, so it is traveling with acceleration A. This is our M1. M1 is also traveling with acceleration A, and it is connected with a string to M2. So M2 is also traveling with acceleration A. So M1, this M will try to force this M1 towards right side with the help of force of friction. Let us suppose that is F1. So equal and opposite will be acting here also, that will be F1, and there is a string that is connected between M1 and M2. Let us suppose it is having a tension T, so there will be T tension here, okay, and the M2 is going to have a force of friction, let us suppose that is given as F2, and it is connected with the string, so there will be a tension T towards the right side. So first of all, let us find out that what will be the maximum value of the friction F1 and F2. We can say that F1 max will be equal to, there will be its M1 weight is given as, M1 is 20 kg. Okay, let me write it here. M1 is given as 20 kg and M2 is given as 5 kg and capital M is given as 50 kg. Okay. So for M1, its weight is 20, so we have in the downward direction there will be 20 g, and this is our M1, and there will be a normal, let us suppose that is N1, which is equal to 20 g. Okay, and this is a friction F1 and tension T. So we say for block M1, so F1 max will be equal to mu into n1, and mu coefficient of friction is given as 0.3. It's given as 0.3, so we have 0.3 into 20 into 10. Okay, so we have maximum friction will be coming as 60 Newton. Next, let us draw for block M2. For block M2, and for block M2 we are going to have, this is our M2, its mass is 5, so we are going to have 5g. Let us suppose the normal N2 whose value will equal to 5g, and there is a tension T and a friction force of F2. You can say our F2 max will be equal to mu into N2, and value of mu is 0.3 and G is given as 10. N2 will be 5 into 10, so we have, so we have F2 max will be equal to 15 Newton. And in both cases this will be also traveling with acceleration A, and this will be also traveling with acceleration A. Okay. So we can write the equation for block M1. For block M1, okay. For block M1, it will be F1 minus T, and that will be equal to M1 to A. Let this be equation number 1. For block M2, we can write T minus F2 will be equal to M2 to A, 3 equation. And for block capital M, okay, for block capital M we can have the equation as, this is our capital M, and it is being applied force of F, and opposite here is F1, and acceleration is A. Okay. So we can write this equation as F minus F1, F minus F1 will equal to MA, equation number 3. Okay. So if we add equation 1 and 2, okay, adding equation 1 and 2, we get T cancels out, so we get this as F1 minus F2 is equal to A can be taken as common, and this will be M1 plus M2. From here we can say our acceleration A, F1 minus F2 will be equal to M1 plus M2. Substitute the value. F1 is our 60, F2 is our 15, and M1 is our 20, and m2 is our 5. From here we can say A will be coming as 45 divided by 25. So we are more interested in sign. So from here we can say that A is equal to positive. So it means all the blocks will travel together with same acceleration. With the same acceleration. So if they are traveling with same acceleration, okay, so we can say from here, this means there is no relative motion between M1 and capital M. Okay, there is no relative motion between M1 and capital M. Okay. Now this was, or if you want to find, we can find out the force also if you need, but okay, so let me solve the force also. So we can say force F minus 60 is equal to M into capital M is given as 50 kg and multiply by A is 45 by 25. Okay, this is our using equation 3. Equation 3. From here we can say that our F will be coming as equal to 150 newtons. Okay. But the important part is that from here we can draw only one important conclusion, that our, you can say, how can I put it, that entire blocks will be moving in the same acceleration. Okay, this was only calculated or conclusion drawn by finding out that whether our A was positive or not. Now the important part in this entire question is from the second part, which is asked. Here it is asked that let the magnitude of force of friction between M1 and M be F1 and between M2 and ground be F2. So for what particular value of F, it is found that F1 is equal to F2. Okay, so we have to find out this condition or use this condition in order to find out the value of the force. Okay, so we are going to use the condition that F1 is equal to twice F2 and then find out the value of the force. Okay, so it means this value of the force is not according to the condition, F1 equal to twice F2. If you want, we can check it also. We know that our F1 is our, or rather we can say our F2 is 50 Newton, and if you want to find out F1 will be coming equal to twice into 15, which will equal to 30 Newton. Okay, but the actual value of F1 which we calculated is 60 Newton. Okay, so we can say, but actual value of F1 calculated is 60 Newton. Okay. Therefore, from here we can draw two conclusions. First is the value of F cannot be 150 Newton, and second, the value of acceleration A cannot be 45 by 25. Okay. You can see value of acceleration cannot be 45 by 25. The value of A cannot be 45 by 25 meter per second square. Okay. So now let's focus on part B, which states that find F under the condition F1 equal to twice F2. Okay. So we already know that the maximum value of F2, max value of F2, which is F2 max, is equal to 15 Newton, and based on the equation we can say that the maximum value of F1, which can we say F1 max, will be equal to twice into F2 max. Okay, or rather we can say twice into 15, which will equal to 30 Newton. So we can say F1 will be coming equal to as 30 Newton, and moreover the maximum value of the calculated maximum value of F1 max is our 60 Newton. Let me check. Yeah, it is 60 Newton. So if you compare, the required value is 30 Newton, available value is 60 Newton. Okay. From here we can say required value of friction, required value of F1 is less than available value of F1. From here also we can conclude that no relative motion between M1 and capital M. No relative motion between M1 and capital M. Okay. So now we are going to use these two values of F2 as well as F1 and find out what will be the value of the force. Okay. So now we are again going to draw the free body diagram. So first is for block M1. So we have acceleration A, and F1 is our 30 Newton now. So F1 is 30 Newton. This is our M1, and we have a tension T. And so we can say here F1 minus T will be equal to M1 into A. We substitute the value. F1 is 30 minus T, and M1 was our 20 kg, so this will be 20. Let us this be equation number 4. Now we for block M2, so we have this our M2, acceleration is A, and T2, and this is going to have a F2 whose value is 50 Newton. Let us put this A as capital A in order to differentiate from the previous one. Capital A as well as capital A. Capital A. So we can write this equation as T minus F2 will be equal to M2A. From here we get T minus 15. Our M2 is 5 kg, so this will be 5 into A. And let this be equation number 5. Now we draw for block capital M. So this is our block capital M. Okay, F force is being applied, and there will be here F1, which is equal to 30, and it is traveling acceleration A. So we can say F minus F1 will be equal to M A. So we can say F minus F1 is our 30, and capital M is given as 50. That is equation number 6. So if we add equation 4 and 5, adding equation 4 and 5, we get T cancels out, so we get this as 30 minus 15 will be, we can take A as common, so this will be 20 plus 5. From here we can find out our A. A will be coming as 15 oblique 25, or you can say this is 3 and this is 5, so we get acceleration as 3 upon 5 meter per second square. Next we can find out tension also. Okay. So we are using equation 3, using equation 5, using equation 5 we get T minus 15 is equal to 5 into 3.5. 5 cancels out, so your tension coming as 18 Newton. Okay. And lastly we can find out the force. So using equation 6, we get F minus 30 is equal to 50 into A. A is our 3 by 5. So this goes as 10, this goes 30. So we can say that our F is equal to 60 Newton. So this completes the question. And the important part in this is that first of all, we assume that everything travels with the same acceleration. Check the sign of acceleration. If acceleration is positive, then we can say that our assumption is same. They are going to travel with the same acceleration. Okay. And herein we are considered mainly in finding out the value of the force, that is capital F, which is, this is the value of F under the condition F1 is equal to twice F2. Okay, F1 is equal to twice F2, and this is also the tension under the condition F1 is equal to twice F2, and we found out the acceleration. This acceleration is also under the condition F1 is equal to twice F2. Okay. So we are mainly interested in finding out the value of force, tension, as well as F1 and F2, which we already calculated under the condition that F1 is equal to twice F2. Okay. This completes the question. Thank you.